Okay, so food security is a huge global issue. With the world's population continuing to rise, we're putting an increasing amount of pressure on our already limited resources, yet we're already failing to feed everyone. And 1.2 billion people around the world suffer negative health as a consequence of extreme poverty. This is the equivalent of 1 in 2 of all of our children. And this can largely be attributed to insufficient food and energy intake, which in a lot of cases is simply because there's not enough food to go round. So my interest lies primarily in trying to tackle this problem from the plant side of things. So can we improve our crops and our crop yields growing on poor soils, which are becoming more and more common in a constantly changing environment? So as with people, heavy metal nutrients like iron, zinc and manganese are toxic for plants when present in excess in the soil, but they're also essential for their nutrition. So under both nutritional extremes, deficiency, so not enough nutrients about, to toxicity when we've got too much, we get stunting of crop plants and yellowing of their leaves. And both of these can lead to large agricultural yield losses, which in turn becomes a problem for food security. This becomes a problem if it's not rectified, and so in a lot of places around the world, they simply don't have the cost, the funds, infrastructure or technology to rectify this, such as in developing countries. And in the UK, we're quite lucky. So although we have got quite a lot of poor nutrient soils, we've also got the technology available to rectify this. So we can add metal-rich fertilizers to improve our yield of our wheat and our barley. But it's expensive, it's another limited resource, and it's really bad for the environment if too much is added. So where does my research come into this? Well, plants have a range of mechanisms in place that allow them to survive under these nutritional extremes, albeit at reduced health. And what I want to know is whether we can exploit these mechanisms to potentially create a plant that has improved tolerance to or improved growth on these poor soils. So what I've done is to genetically interfere with some of these mechanisms and then grow these plants on different conditions to see what happens. Actually, what's happened is I've managed to create a plant that grows better under nutrient deficiencies. So under conditions like those we sometimes see in the UK, where there's not enough of these nutrients to go round, we get healthier, happier, larger plants without having to add extra nutrients to supplement back into the growth environment. And so everything I've done so far has been in a non-crop plant, and I'm currently in the process of scaling this up into wheat, so more agriculturally relevant species, and seeing what we get. And if we get the same effect as we do in my non-crop plant, in theory, plants like these could go a long way to improving food security because we get a better yield on poorer soils without the need, cost, and environmental issues of having to add extra fertilizer. Thank you.